and unmatched records from left and right side tables. So now continuation of outer Jan. See here. Yesterday we have seen how to get matched records. You already know. EquiJan we have to use. And how to get matched records and unmatched records from EMP table, you know, left outer Jan. And how to get matched records and unmatched from right table, you know, right outer Jan. And how to get matched records, unmatched from left and unmatched from right, you know, full outer Jan. Now our requirement is, we want to get only unmatched records from EMP table. See, left outer Jan means what? That gives matched records plus unmatched from left table. Now what is our requirement? We want to get only unmatched records from EMP table. That is our requirement. So the question is, display the employee records along with department details. Sorry. So display the employee records to whom department is not assigned. So we want to display the employee records to whom department is not assigned. Means we want to get only unmatched records. So only unmatched from EMP table. So only unmatched records from left table we want to get. So to get only unmatched records from left table, okay, employee details will be there, but department details will not be there. Those records we want to get. So we want to get unmatched records from left table. So left outer Jan means it gives matched and unmatched records from left table. But we want to get only unmatched records from left table. So we have to write left outer Jan plus one condition we need to write. Okay. See here, left outer Jan plus condition we have to write. If you want to display the unmatched records from left table, only unmatched records, we have to write left outer Jan plus one condition we have to write. So now I'm writing the left outer Jan in Oracle style. So we want to get employee details. So employee name, salary. What we write? E dot E name, comma E dot salary. Employee details. D dot D name, department name, D dot location. Okay, from which tables? From EMP table, E, comma, department table, D. Okay, where left outer Jan we are writing. So left outer Jan means E dot department number equals to D dot department number, right plus symbol at right side. So right side we are writing the plus symbol. Now this is what left outer Jan. It gives matched records and unmatched records from left table. Our batch schema I am opening. C hash hash. Batch 2 PM. The password is Naresh IT. So see here. Observe. This query we are running now. This is left outer Jan. This is left outer Jan. See, sorry. Dot spelling mistake is there. Dot comma typed here. Okay. So this is the condition. Okay. Observe here. See what it is giving. It is giving matched records. It is giving matched records. These are the matched records. And these AA, BB are the unmatched records. But what is our requirement now? We want to get only unmatched records. So we need to write one more condition. And so unmatched from left table we want. Unmatched from left table means employee details will be there, but department details will not be there. Unmatched records from left table we want. Listen carefully. For example, this AA employee salary is 5,000, BB employee salary is 4,000. I'm taking. So now these employee details are taken from which table? AMP table. And these department details will be taken from which table? Department table. What is our requirement? Unmatched records we want. So these are the matched records. Blake, Turner, these are the matched records. These are the matched records. Unmatched records AA, BB we want. So for these unmatched records, no department name will be there. So here D dot D name value is what here? Null. If D dot D name value is null, display them. For matched records, department name is there or not? Yes, not null. For matched records, department name not null. For unmatched records, department name null. If department name is null, give those records. So this condition we have to write. Once again, I'm repeating. So this AABB, these employees, no department name is assigned. So here department name value is null here. If department name value, D dot D name value is null, display those records. For James, department name is there. For Turner, department name is there. For Blake, department name is there. Here department name is not null. For them, department is assigned. Our requirement is to whom department is not assigned, those employee records we want. So department not assigned means those employees department name value will be null. This condition we have to write. So left outer Jan plus condition. What is the condition? D dot D name is null. So and D dot D name is null. This is the condition. So if we write like this, it will give only unmatched records. So this is the way of getting only unmatched records. Observe here. I'm copying this. It is giving only unmatched records from left table. So left outer Jan plus condition. If we write left outer Jan plus condition, next, this is Oracle style. Now the same query we want to write in ANSI style. So in the ANSI style, this is left outer Jan. So for left outer Jan, we use the keyword left outer Jan only. Okay, so EMPE left outer Jan, department D, and in on class we have to write the Jan condition, and don't use any plus symbol here. Sorry, don't use any plus symbol, and we write this condition in which class? Where class? In the where class we are writing the condition. I'm copying this. Observe, this one also give only unmatched records from left table. Only unmatched records it gives. Observe. See here, same result it is giving. Okay, so this is the ANSI style. We are using keyword means ANSI style. And this is the Oracle style. So left outer Jan plus condition means it gives only unmatched from left table. Now our requirement is next one. Display the department names which are not having. Display the department names which are not having employees. Display the department names which are not having employees. Means the question is, we want to get unmatched records from department table, from right table. We want to get unmatched records from right table. We don't want to get matched records, only unmatched records from right table. So what we have to use here, right outer Jan. If we write right outer Jan, it gives matched and unmatched from right table. Both it gives, but we don't want to get matched records. So we need to write one more condition here. Right outer Jan plus condition we need to write. Okay, now I'm writing right outer Jan in Oracle style. Now what we have to write? What we have to write? Select right outer Jan. Select E dot E name, E dot salary, D dot D name, D dot location from EMPE, comma, department D, where joining condition is E dot department number equals to D dot department number. We want to write right outer Jan. So write plus symbol at left side. So this is the right outer Jan. If we write like this, what happens here? It gives matched plus unmatched from right. So it gives matched plus, these are the matched records, and unmatched from right it is giving. What is our requirement? We want to get only unmatched from right table. If you observe this operations record, this is the unmatched record. For this, so for the department is there, employee is not there. Employee is not there means this is E dot E name value. E date E name value is what? Null. So department is there, but in that department employee is not there means employee value will be null here. So E dot E name is null. Right outer Jan plus write this condition. So department is there, but in that department employees are not there means employee name will be null here. So write E dot E name is null. So right outer Jan plus condition. It gives only unmatched records from right table. See here. Now it is giving only unmatched records from right table. See here employee name is null. So it is giving. So operations department is not having employees. So right outer Jan plus condition. Now the same query, this is Oracle style. The same query we want to write in ANSI style. ANSI style is very easy. Just we use keyword. So which keyword we have tried here? This is right outer Jan plus condition. So which keyword we have tried? Right outer Jan. Right outer Jan. Okay. And in on clause we have tried the Jan condition. Don't use any plus symbol. E dot department number equals to D dot department number, and write this condition in the where clause. So this is right outer Jan plus condition. It gives only unmatched records from right table. See here, same result it is giving. Department is there, but in this department employees are not there. Okay. So this is the way of getting unmatched records from right table. So in today's session, just we discussed two queries. One is how to get unmatched records from left table. So how we can get left outer Jan plus condition. And how to get unmatched records from right table. Just right outer Jan plus condition. This is right outer Jan plus condition. Okay. Now our requirement is we want to get unmatched records from left table, unmatched from right table. We don't want to get matched records. So full outer Jan plus condition. Okay. So display the employee records. Display the employee records to whom department is not assigned, and also display the department names. Also display the department names in which employees are not existed. In which employees are not existed. So unmatched from left, unmatched from right. So we need to write. So here we want to get unmatched records from left and right. So we don't want to get matched records here. Only unmatched from left and right we want to get. So we have to write full outer Jan plus conditions. Full outer Jan plus conditions. Okay. So in Oracle style, how to write full outer join, you already know. Left outer join union, right outer join. Left outer join union, right outer join. So what we are writing, select E dot E name, comma, E dot salary, comma, D dot D name, comma, D dot location from EMPE, comma, department D, okay, where E dot department number equals to D dot department number plus symbol, we are writing at right side. Means this is left outer join. Okay. So what is our requirement? We want to get only unmatched records from left table. So we need to write one more condition, and condition is, so employee details will be there, department details will be not there. So department name value will be null. D dot D name is null. So this is left outer join plus condition. Union, right outer join plus condition. So for right outer join, we write this plus symbol at left side. So it is right outer join. So we want to get the department names in which employees are not existed. So E dot E name value will be null. So E dot E name is null. So this is what left outer. This is left outer plus condition. Means we get unmatched records from left table. This is right outer plus condition. Means we get unmatched records from right table. In between that, we are applying union. So we are getting unmatched from left table, unmatched from right table. Full outer join plus conditions. So it gives unmatched records from left and right tables. It gives unmatched records from left and right tables. Observe here. See, these are unmatched records from left table, and this one is the unmatched record from right table. Full outer join. So here, left outer join union, right outer join means full outer join. Full outer join plus conditions are there. So full outer join plus conditions means it gives unmatched from left table and unmatched from right table. Unmatched from left table means department name will be null. Unmatched from right table means employee name will be null. Those conditions only we are writing. If employee name is null, give those records. If department name is null, give those records. Next, this is Oracle style. ANSI style is very easy. So just simply write, select E dot E name, comma, E dot salary, comma, D dot D name, comma, D dot location from EMPE. For full outer join, what we write? Full outer join keyword. Full outer join, department D. Write join condition in the on clause. On E dot department number equals to D dot department number. And write the conditions in the where we want to get the employee records to whom department is not assigned. Means the department name will be null. D dot D name is null. Or, okay. So the departments which are not having employees we want. So employee name will not be there. E dot E name is null. So observe here. Full outer join plus conditions. In ANSI style we are writing, copying this query. So it gives unmatched records from left table and unmatched records from right table. So total now in the joins, total 7 cases we discussed. What are those 7 cases? I am showing through the Venn diagrams of joins. So total 7 cases you know now. What are those 7 cases? Observe. So assume that this is first table. Okay, and this is the second table. Okay, so one circle is first table, another circle is second table. So like this, total 7 Venn diagrams I'm taking. Second, third, okay. So one more case I'm taking. So total 7 cases are there. What are those? Observe. See here. For example, we want to get matched records only. Assume that first table is EMP table. This first circle is EMP table. Second circle is department table. 2 tables. Okay. First table, EMP table. Second table, department table. So we want to get only matched records. We want to get only matched records. Matched records only we want to get. In EMP table and department table, matched records. This is a Venn diagram for matched. Okay. So what we have to use here? What we have to use? Equigen. Matched records means what we have to use? Equigen. For example, our requirement is we want to get matched records and unmatched records from left table. Observe the Venn diagrams here. This is matched record. And this one is matched records plus unmatched from left table. Okay. Left outer chain. This is left outer chain. Okay. Next, we want to get matched records and unmatched records from right side table. Right outer chain. Right outer chain. So we want to get matched records, unmatched from left table, unmatched from right table. Full outer chain. Okay. We want to get only, today we discussed this, only unmatched records from left table. Left outer plus condition. Left outer plus condition. Okay. Next, we want to get unmatched records from right table. Right outer chain plus condition. Right outer chain plus condition. Okay. We want to get only unmatched records from left table and unmatched from right table. Full outer chain plus conditions. Full outer chain plus conditions. So till now we have seen these 7 cases in the joins. So to get only matching records, equigen. So employee records along with department details, equigen. So employee details, matching records, and also employee details with department details. And also we want to get the employees to whom department is not assigned, left outer. Okay, right outer means matched records plus unmatched from right. Full outer, matched records, unmatched from left, unmatched from right. Left outer plus condition means only unmatched from left. Right outer plus condition means only unmatched from right. Okay, full outer plus conditions means left, unmatched records from left, unmatched records from right. So these are the Venn diagrams. Just in the Google, you can search for Venn diagrams. Okay, just in the Google, you can search for Venn diagrams of giants. So Venn diagrams of giants. It will display the messages here. It will display the images. Observe here. This is the image. So like this, you will get the images. Venn diagrams you will get. So image, observe. See here. Observe. This one is what? Equigen, inner chain. See here. He is telling that this is table A, this is table B. Inner chain means only matched records it gives. One case. Next, observe this case. Observe this case. Matched records plus unmatched from left. Left outer chain. I already told. You can also write left chain. Writing outer is optional. Left chain also you can write. Okay. Next, third case. This one. Right outer chain. Right chain. Right outer chain. Okay. Matched records. Unmatched from right table. So 3 cases are over. Next, this is unmatched from left. This case, unmatched from left, only unmatched from left. Left outer Jan plus condition. Left outer Jan plus condition. Okay, observe this one. Okay, we want to get only unmatched from right side table. Okay, right outer Jan plus condition. Okay, this is full outer Jan. See, matched records, unmatched from left, unmatched from right. And this one is unmatched full outer Jan plus conditions. Full outer Jan plus conditions. Full outer Jan plus conditions. Unmatched from left, unmatched from right. We don't want to get matched records. So total, these are the 7 cases. Now you know. In the Jan, 7 cases you know now. Next, this is about outer Jan perfectly. Inner Jan and outer Jan are over. Okay. Now next category is what? Non-equijan. So equijan, outer Jan are over. Next one is non-equijan. Observe. So equijan means what? Jan operation will be performed based on equality condition. Non-equijan means Jan operation will be performed other than equality condition. Non-equi. Equi means Jan operation will be performed based on equality condition. Non-equi means Jan operation will be performed based on other than equality condition. So equijan means if Jan operation is performed, based on equality condition, then it is called equijan. Equijan. Okay, for example, we are writing like this. E dot department number equals to D dot department number. This is equijan. Non-equijan means if Jan operation is performed based on other than equality condition. If Jan operation is performed based on other than equality condition, then it is called non-equijan. For example, we are writing like this. So if we write E dot department number equals to D dot department number. If we write like this, this is called what? Equijan. Okay. So equijan means equality condition we use. Non-equijan means we use other than equality condition like that. Ma'am, please don't operate mobile. E dot department number not equals to D dot department number. So now here, is it equality condition other than equality condition? Other than equality condition. So for example, if our requirement is, we want to get the departments in which employee is working, we write like this. We want to get the departments in which employee is not working, we write like this. Okay. So if department number is not matching with the department number, so if employee table's department number not matching with the department table's department number, it performs Jan. So for example, here 10 is there. In the department table, 10, 20, 30 are there. Now 10 not equals to 10, condition false. It will not perform Jan operation. 10 not equals to 20, performs Jan operation. 10 not equals to 30, performs Jan operation. If not equal, performs Jan operation. Like that. Other than equality condition, not only not equals to, E dot department number greater than D dot department number. Suppose E dot department number less than D dot department number. All these are comes under non-equijan. So to understand this non-equijan, I'm giving one example here. We want to display the employee records along with display the employee records with salary grades. With salary grades. This is our requirement. So we want to display the employee records along with salary grades. So what we are writing? Here two tables are there. One is EMP table. EMP table data is employee number, employee name, salary. Okay. There is another table is there. For non-equijan, common column is not required here. For equijan, common column is required. For non-equijan, common column is not required. So sal grade table is there. The sal grade table, salary grades are there. Grade, low salary and high salary. Here employee details are there like 1001. Employee salary is 2000. 1002. Employee salary is 4000. 1003. Employee salary is 1100. Okay. 1004. Employee salary is 3500. Okay. 1005. Salary is 5000. So like this, salaries are there. And in the salary grade table, grades are there. Like if salary is between 700 to 1200, this is first grade. If salary is between 1201 to 1400, this is second grade. If salary is between 1401 to 2000, this is the third grade. If salary is between 2001 to 3000, this is the fourth grade. And if salary is between 3001 to 5000, this is the fifth grade. So like this salary grades are there. Now, first employee salary is 2000. Means his salary is falling under which grade? First grade means minimum salary 700, maximum salary 1200. If salary falls under this range, that is first grade. If salary falls under this range, second grade. So like that, 2000 falls under which range here? Third grade. So what we have to check here, for EMP table, alias name is E. For sal grade table, alias name is S. So to access this salary value, what we have to write? E dot salary. E dot salary between this value and this value we have to check. Okay, how can we access this value? S dot low salary. This is low salary column value or not? What is the table name? S. S dot low salary. How can we access 2000? S dot high salary. If E dot salary between S dot low salary and S dot high salary, then give this grade. That's it. Here this is the Jan condition we need to write. E dot salary value, we are comparing with this low salary and high salary. E is 2000 falling under 700 and 1200, it checks. Not falling. Okay. E is 2000 falling under 1201 and 1400, it will check. Not falling. Is 2000 falling under 1401 and 2000, it will check. Yes. Falling. So we want to get this salary grade now. So which condition we have to write here? The Jan condition is where this is E dot salary value. E dot salary value between this low salary and high salary are not, we are checking. So how can we access this low salary? S dot low salary. Okay. And how can we access this high salary? S dot high salary. For this table alias name E, for this table alias name S. To access this salary, E dot salary. To access this low salary, S dot low salary. To access this high salary, S dot high salary. So this Jan condition we need to write here. Jan condition we are using between and here. Jan condition we are using between and. Okay. Not equal to operator. Okay. So this is other than equal to. This is other than equal to. So you can say this as the non-equivalent. If you are using equal to operator, equivalent. If you are using other than equal to operator, non-equivalent. In this example, we use non-equivalent. Our requirement is we want to get like this: employee details along with salary grade. 2000 means which grade? Which grade? Third grade. Third grade. 4000 means which grade? Fifth grade. Okay. So 1002. Just a minute. Salary values also I want to take. So 2000. Employee name, salary. Employee name, salary, and salary grade. So 2000 means third grade. Okay, next B employee, salary 4000. 4000 means fifth grade. Next C employee salary 1100. So 1100 means which grade? Okay, first grade. 1100 means first grade. Next 3500. 3500 means fifth grade. So D 3500 fifth grade. Next E 5000 fifth grade. So E 5000 fifth grade. So this is our requirement. So now observe here. This is the E name and this one is the salary. This one is the grade. So now in this E name salary, these columns are in which table? EMP table. This grade column is in which table? Sal grade table. From two tables we want to retrieve the data. So we have to use which concept here? Jan's concept. Okay. But here, what is our requirement? This employee salary is between this range or not, we want to check. So how can we access this employee salary? E dot salary. Between this range or not, we want to check. How can we access this low salary? S dot low salary. S dot low salary and high salary. S dot high salary. If salary is falling under this range, that takes this grade value. Okay. So we are writing like this. Select which columns we want? Employee name, salary, grade. So E dot E name, comma, E dot salary, comma, S dot grade. From which tables we are retrieving? EMPE, comma, sal grade, S. Where write the Jan condition. E dot salary between S dot low salary and S dot high salary. That's it. So this is the Jan condition. Here, this is the Jan condition. In the where clause, we are writing Jan condition. Is this Oracle style or ANSI style? Oracle style. Okay. So this is the Oracle style. So here sal grade table is not ready. We need to create. In the Google Classroom, I already provided one sample tables file. In this file, EMP table creation, insertion queries are there. Department table creation, insert queries are there. And like that, sal grade table is there. Observe. Sal grade table and inserting queries are there. I'm copying this. So sal grade table query, creation query and insertion queries are there in the file. So we are copying them and we are saving this data. Observe, open the table, select star from sal grade. See here, salary grades are there. 700 to 1200, first grade. 1201 to 1400, second grade. 1401 to 2000, third grade. 2001 to 3000, fourth grade. 3001 to 9999, fifth grade. Salary grades are here and employee details are there in the employee table. What is our requirement? We want to get employee salaries and their salary grades. So we are writing the non-equivalent like this. Select E dot E name, comma E dot salary, comma S dot grade. S dot grade from EMPE, comma sal grade S. Okay, where E dot salary between S dot low salary and S dot high salary. Okay, sorry. Sal grade spelling mistake is there. Sal grade spelling mistake is there. Observe here. It is displaying the salary grades. Observe. So Smith salary 960. 960 falling under which grade? Observe here. 960 falling under which grade? First grade. So that's why it is giving first grade. So 960 falling under first grade. Okay, next 1092 also falling under first grade. First grade means from where to where? 700 to 1200. 1201 to 1400 second grade. Okay, observe here. This is between 1200 to 1400. 1201 to 1400. So second grade it is giving. From 1401 to 2000. Third grade. See. Third grade it is giving. So these are between 2000. So it is giving third grade. 1401 to 2000. Third grade. Okay. 2001 to 3000. Fourth grade. So we got correct answer. So this is the way of using non-equijan. Here this is the joining condition. If this condition is satisfied, that displays the grade here. Okay, if this condition is satisfied, that performs join operation. According to this example, here it checks is 2000 falling under 700 and 1200. It is checking. No. 1201 and 1400. No. 1401 and 2000. Yes. So it performs join operation. So this record will be joined with this record. Because of this reason, now we can access grade. So next, 4000 is 4000 value falling under the 700 or and 1200 or not? It is checking. Not falling, not falling, not falling, not falling. Yes, falling. So this 4000 record will be joined with this fifth grade. So 4000 salary is fifth grade. Like this, it performs a join operation. 1100. 1100 means first grade. 3500, fifth grade. 5000, fifth grade. So like this, it performs a join operation. So here to perform this join operation, we are not using equal to condition. We are using between and. So non-equijan. So now this is the Oracle style. The same query we want to write in ANSI style now. In ANSI style, we write like this. In ANSI style, okay, to separate, see, listen carefully. Inner join means that gives matched records. Inner join means if condition is true, if condition is true, that gives those records. So non-equijan also inner join only. So because this condition is true, that gives the records. Means matched records only it is giving. So inner means, the meaning of this one is, inner means, okay, if records falls under this condition, okay, E dot department number equals to D dot department number. Okay, we are writing like this. E dot department number equals to D dot department number. If record falls under this condition, that gives, means match record. For example, we are writing like this. E dot salary between S dot low salary and S dot high salary. So if record falling under this condition, that record will be displayed, means match record only. It gives match record only. That's why non-equijan also inner jan only. Outer means that gives matched plus unmatched. Inner means only matched records. If this condition true means matched record. This condition true means matched record. So non-equijan also inner jan only. Because of that reason, here also we use inner keyword only. To say more clearly, There are actually three types are there. One is inner Jan, one is outer Jan, another one is cross Jan. That's it. Non-equi Jan also comes under inner Jan. Self Jan also comes under inner Jan. So if you are getting confusion with this, don't write inner here. Simply you can write Jan also, no problem. Jan also you can write. So this is the non-equi Jan. Non-equi Jan means other than equality condition we use. Here we have to write this Jan condition in which clause? On clause. In the on clause, write this Jan condition. This Jan condition is not using equals to operator. So non-equi Jan. Non-equi Jan also inner Jan only. Okay. Sorry. Here spelling mistake is there. Salgrade. Spelling mistake is there. Observe. See, it is giving the employee details along with salary grades. 960 first grade. Okay, 1320 second grade. Like this it is giving. This is ANSI style. So inner Jan means it gives matched records. In case of non-equi Jan, other than equal to condition we are writing. So if this condition is true, that is displaying, that is performing Janning operation. So it displays only matched records. So that's why non-equi Jan also inner Jan only. So this is about non-equi Jan. Next category is self Jan. Observe here. Now you know three categories. Equi Jan, you know, based on equality condition, it performs Jan operation. Outer Jan, you know, it gives matched and unmatched records. Non-equi Jan, you know, other than equal to we write. Next one is what? Self Jan. So what is this self Jan? See. So self Jan means if a table is Jan to itself, if a table is Jan to itself, if a table is Jan with that table only, if a table is Jan to itself, then it is called self Jan. If a table is Jan to itself, we are calling that as the self Jan. It means one record in one table. Okay. One record in one table. A record in one table is joined with another record in same table. Here we are not working with two tables. Here we are working with one table. The self Jan, we are not working with two tables. We are working with one table. So a record in one table is joined with another record in same table. Then it is called self Jan. Then it is called self Jan. Now to understand this, I am giving one example. Try to understand. In the EMP table, some data is there like employee number, employee name, job, salary, and manager IDs are there. Okay, so job, salary, and manager IDs are there. So this is the EMP table. Some data is there like 1001 employee. Employee name is A. His job title is manager. Okay, job title is manager, and he is the manager. He has no manager, so manager value is null. 1002 employee is clerk. Okay, he is reporting to this clerk. Manager is A. A is the manager for B. So in the MGR column, we maintain the manager ID. Manager is also one employee. So this employee number we maintain as the manager ID here. Okay. For B employee is working under which manager? 1001 manager, means A manager. So manager is also one employee. That employee number we are writing as the manager ID here. So A is the manager here. B is working under A manager. So for B, who is the manager? 1001 is the manager. 1001 means whom? A. So like this, one more employee is there. 1002 employee, C employee is a salesman. He is working under same manager. His salary is 4,000. He is also working under same manager, 1001. For C employee, who is the manager? 1001 is the manager, A. Next, 1003, this employee is the manager of another department, and his salary is 8,500. He is the manager, so manager ID value null. 1004, employee name is E. His job title is clerk. He is working as clerk under manager D. Under manager D means manager ID will be 1003. So manager ID is 1003. Next, 1005 employee. He is working as analyst. He's working as analyst. Okay. His salary is 3,000. Salary is 3,000. He is also working under the same manager, 1003. Now our requirement is we want to display employee details. We want to display employee details along with manager details. This is our requirement. We want to display employee details along with manager details. This is our requirement. So here employee name we want. That employee salary we want. Manager name we want. Manager salary we want. This is our requirement. So we want to get output like this. So for this, what we have to do, observe here. Here only one table is there. In the same table, employee details are there, manager's details are there. Now this table should be joined with that table only. What we have to do is, for this B employee, who is the manager? 1001. So manager is also one employee, right? So that's why this manager ID, we are comparing with employee number. This is the manager ID. We are comparing with employee number. If this manager ID and employee number both are matching, perform join operation. Now 1002 record joined with this 1002 record joined with 1001 record. For 1002 B employee, salary is 5,000. His manager is A. Manager salary is 9,000. So one record in one table, we are joining with another record in the same table. So this is called self-join. Okay. In the same way, next employee, manager ID is what? 1001. Is 1001 matching with 1001 or not? We are checking. Yes, 1001 is matching with 1001. So this 1002, sorry, number is same here. I'm sorry. So here I'm taking 3. This is 4. and this one is 5 and this one is 6. Okay. So here this 1001 is matching with 1001. So 1002 record we are joining with the 1001. And this 1001 matching with 1001. So 1003 record we are joining with the 1001. So like this, one record in table we are joining with another record in the same table. This concept is called self-join. So for our understanding purpose, here only one table is there. But for our understanding purpose, I am taking this as the two tables. Virtually, we are taking two tables. But actually, there are one table only. Actually, there is one table only. For our understanding purpose, I am taking this as two tables. For this first EMP table, I am giving as alias name as E. E means employee details. For this second EMP table, so actually one table is there. For that same EMP table, we are giving alias name as M. Actually one table is there, but virtually we are taking as two tables. Now compare this manager ID matching with this employee number or not. If both are equal, that should perform join operation. So this is also equi-join only. This is also inner join only. This is also inner join. Self-join is also inner join, but only with one table we are working. That's why we are calling this as the self-join. So now we are comparing this manager ID value with the employee number. So here this manager ID value not matching with any employee number. It will not perform any join operation. Next 1001. Is 1001 matching with 1001? Yes. So this B record will be joined with A record. Next 1001. Is 1001 matching with 1001? Yes. So C record will be joined with A record. Next this is null, not matching with anyone. It will not perform join operation. Next 1003. Is 1003 matching with 1001? No. 1002? No. 1003? Yes. Performs join operation. So for E employee, who is the manager? Okay, sorry. 1004, right? $1,004 is the manager, right? So here take 1004. We changed the employee numbers, but we didn't change the manager ID here. So that's why we got the problem. Okay, no problem. Now, see here, 1004. Is 1004 matching with 1004? Yes. So for E employee, who is the manager? D is the manager. Next, is 1004 matching with 1001? No. 1002? No. 1003? No. 1004? Yes. So this record will be joined with this record. So like this, it performs a join operation. So now, this is the employee name. How can we access E dot E name? B. E dot salary. E dot salary means 5,000. Okay, this is M. M dot E name means A. M dot salary means 9,000. So these are the employee details. These are the manager details. For B employee, salary is 5,000. His manager is A. A salary is 9,000. Employee details, employee salary details. Manager details, manager salary details. So here actually one table is there. For our understanding purpose, virtually we are taking as two tables. So from this E table, we want to get this employee name. From this E table, we want to get employee name and salary. So these are the employee details. To access this E name, we write E dot E name. To access this salary, we write E dot salary. These are the employee details. We want to access manager details. This is M dot E name. And this one is M dot salary. So M dot E name means manager name it will give. M dot salary means manager salary it will give. So we are writing like this. Select employee name we want. So employee name, for employee details, E alias name. For manager details, M alias name. So to get employee name, what we write? E dot E name. To get employee salary, what we write? E dot salary. So E dot E name, comma, E dot salary. These are the employee details. So for our understanding purpose, I am giving name as employee name here. Okay, for this, I am giving alias name as employee salary. These are the employee details. Next, manager salary we want, manager name we want. How can we access this manager name? M dot E name. So M dot E name. Okay, for this, we are giving alias name as manager name, comma, manager salary we want, M dot salary. Manager salary. From which tables we are retrieving? From EMP table, E, comma, from the same EMP table, M. For the same EMP table, we are giving alias name as E and M. Where, write Jan condition here. What is the Jan condition here? This manager ID value we are comparing with employee number. So E dot manager ID is equals to M dot employee number. This is the Jan condition. So if manager ID is matching with employee number, perform Jan operation. So we write the Jan condition as E dot MGR equals to M dot employee number. E dot MGR equals to M dot employee number. So this is the self Jan. From how many tables, on how many tables we are performing Jan operation? One table only. The same EMP table will be janned with another record in the same EMP table. Self Jan. See here. According to this example, observe here. Select employee number, E name, salary, manager ID from EMP. Observe here. What happens here is, this is the manager ID. This is the manager ID 7902. Okay, so this is E dot manager ID that compares with M dot employee number. So now E dot manager ID value is what? 7902. Is 7902 matching with 7369? It is checking, not matching. Okay, so for all this, I'm taking another example. 7698 I'm taking because 7902 in the below, 7698 I'm taking. This is what? This is the manager ID from EMP table, E dot MGR value. Okay, we are comparing with M dot employee number. So this manager ID value we are comparing with employee number. Is 7698 matching with 7369? No. 7499? No. 7521? No. 7566? No. 7654? No. 7698? Yes. So Allen record will be joined with Blake. So now employee name is Allen. His salary is 1840. His manager name is Blake. His salary is 3277. So Allen record joined with Blake here. Okay. So one more example. For example here, 7839 is there. For Jones, 7839. Is it matching with 7369? No. Okay. 7839. Here it is matching. So 7839 is matching with 7839. So for Jones, who is the manager? King. So Jones record will be joined with King record. One table record joined with another record in the same table, self join. So finally, we are writing the query here. Observe, I'm writing the query. What we write? E dot E name, employee name. E dot salary, employee salary. M dot M dot E name, manager name. M dot salary, manager salary. So for this, we are giving alias name as employee name. For E dot salary, we are giving alias name as employee salary. Okay. For M dot E name, we are giving alias name as manager name. And for M dot salary, we are giving alias name as manager salary. From which tables? From EMP E, EMP M, where E dot manager, employee tables manager ID, we are comparing with manager tables employee number. So if employee tables manager ID matching with manager tables employee number, join them. So we get employee details along with manager details. See here. For Scott employee, Jones is the manager. For Allen Blake, just now we have seen. For Allen, Blake is the manager. Okay. So like this, it is performing. For Jones, King is the manager. So these are the employee details. These are the manager details. Okay. Now, my requirement is one more question on self-gen. So this is which style? Oracle style. The same query we want to write in ANSI style now. In ANSI style, I already told self-gen also, inner gen only. Self-gen also, inner gen only. Because of that reason, here which keyword we use? Inner gen. Okay, this gen condition we have to write in the on clause. I'm copying this. So self-gen is also equi-gen only, inner gen only, equality condition we are using. Okay, observe, it is displaying employee details along with manager details. Now my requirement is, I want to get the employees who are earning more than their manager. I want to get the employee records who are earning more than his manager. Now, this column is what? Now, observe just a minute. Now, this column is what? Employee salaries. This column is what? Manager salaries. What is our requirement? We want to get the employee records who are earning more than their manager. For Scott, who is the manager? Jones. What is Scott salary? 3,600. What is his manager salary? 3,570. Is he earning more than his manager? Yes, we want to get this. Next employee, Ford. Ford salary is what? 3,600. His manager salary? 3,570. Is he earning more than his manager salary? Yes. This record also we want. Allen employee, 1840. His manager salary? 3,000. Is he earning more than his manager? No. We don't want. Allen is not earning more than his manager. Okay. What is also not earning more than his manager? Martin also not earning more than his manager. Turner also not earning. James also not earning. Miller also not earning. Only Scott and Ford, those two employees are earning more than their manager salary. So, how to get employee salary, you already know. How to get employee salary? E dot salary. How to get this manager salary, we already know. M dot salary. If E dot salary greater than M dot salary, display the record. E dot salary means employee salary. M dot salary means manager salary. If employee salary is greater than manager salary, display the record. So self-gen plus condition we are writing. The question is, we want to display the employee details who are earning who are earning more than their manager. So the employees who are earning more than their manager we want. So we are writing self-Jan here. For employee name, E dot E name. For employee salary, E dot salary. Okay. For manager name, M dot E name. For manager salary, M dot salary. Okay. For this E dot E name, we are giving alias name as employee name. For this E dot salary, we are giving alias name as employee salary. Okay. If anyone is not having interest, please don't come. If you are coming here, please be quiet and listen. Don't disturb others. All are not coming for entertainment. Okay. Don't become problem for others. Because of your talking there, I am getting disturbance. Even other persons are also getting disturbance. From the beginning of session, some members are talking. Why are you coming? If your intention is chatting here, don't come. The outside you can do chatting, you can do enjoying. So E dot E name means we are getting we want to get employee name. E dot salary means employee salary. M dot E name. M dot E name. M dot E name means manager name. M dot salary means manager salary. Okay. From which tables? From EMP table E, comma EMP table M. For the same EMP table, we are giving alias name as E. For the same EMP table, alias name is M. EMP table is joined with EMP table records only, self-Jan. Okay, where the joining condition is E dot MGR equals to M dot employee number. E dot MGR equals to M dot employee number. So if manager ID is equals to the employee number, it performs Jan operation. So we will get all employee records and managers, all employee records along with manager details. If we write like this, it will give all employees records along with manager details. But we don't want to get all employees records. We want to get the employee records who are earning more than manager. So we need to write one more condition, and employee salary means E dot salary. Okay, manager salary means M dot salary. If employee salary is greater than manager salary, display that record only. This is the Oracle style. See here. So Scott and Ford, two employees are earning more than their manager salary. Observe here. These salaries are more than manager salary. So the employees who are earning more than manager, we are displaying here. So E dot salary greater than M dot salary. If this condition is not there, all employees and managers details it will give. Okay. Because of condition, the employees who are earning more than manager, it is giving. The same query we want to write in ANSI style. So I already told self-Jan is also inner Jan. So we are using the keyword inner Jan, and write this Janning condition in the on class and write this condition in the where class. So this is ANSI style. I'm copying this. Okay, observe here. See. So sorry. After on space is not there. After on space is not there. That's why it is giving error. See here. So this is the ANSI style. It is giving the employee records who are earning more than their managers. 2 employees are earning more than their managers. Observe here, manager salary 3,570, employee salary 3,600, more than manager salary. So this is about self-Jan. Self-Jan is over. Last one is cross-Jan. With this, Jan's topic will be over. This cross-Jan can be also called as product Jan, or you can also call this as Cartesian product Jan. Okay. So each record in one table, cross-Jan means in this, each record in one table will be janned with. So each record in one table will be janned with every record in another table. Each record in one table, if each record in one table is janned with, if each record in one table is janned with every record in another table, then it is called cross-Jan. Cross-Jan. Okay, or you can say product Jan, or you can say Cartesian product Jan. In the mathematics sets chapter, you learned Cartesian product. If A set elements are 1, 2, 3, if B set elements are 4, 5, we want to find A cross B here. A cross B. A cross B means what are the A elements? 1, 2, 3. What are the B elements? 4, 5. Each element in A set will be janned with, will be paired with each element in the B. Means 1, 4, 1, 5. This is one pair. Okay. Next. Okay. 2. 2 will be janned with 4. 2 will be janned with 5. So 2, 4, 2, 5. Next. Next one is 3. 3 will be janned with 4. 3 will be janned with 5. 3, 4, 3, 5. A set has how many elements? 3. B set has how many elements? 2. A cross B means how many elements we will get? 6. How many pairs we will get? 6. 6 pairs we will get. So this is A cross B. So each element in A janned with every element in B. Each element in A janned with every element in B. Each element in A janned with every element in B. So here in the mathematics, we are taking elements. In our Oracle, we take records. That's it. So for example, here one table is there. Group A table is there. Our International Cricket Board is maintaining tables like this. Group A. So they divided teams into 2 groups. One is Group A, another one is Group B. They divided cricket teams into 2 groups. Group A, Group B. So Group A and Group B. In the Group A, some countries are there. They are maintaining data like this. Country ID, country name. In the Group B table, they are maintaining country ID and country name. Group A, ID is 10 for India. Okay, 20 is the code for Australia. 30 is the code for West Indies. And in the Group B, 40 is the code. For example, I am taking Pakistan. 50 is the code for England. Okay, 60 is the code for New Zealand, like this. Our requirement is each team in the Group A should play with every team in the Group B. Each team in the Group A should play with every team in the Group B. Means India should play with Pakistan and India should play with England and India should play with New Zealand. This is our requirement. And in the same way, Australia should play with Pakistan, England, and New Zealand. Australia should play with Pakistan. Australia should play with England, and Australia should play with New Zealand. In the same way, West Indies also should play with Pakistan, and West Indies should play with England, and West Indies should play with New Zealand. So each record in Group A should be joined with every record in Group B. This is our requirement. In such type of situations, we have to use cross join. In the Group A, how many records are there? 3. In the Group B, how many records are there? 3. In the cross join, how many records we are getting? 9. 9 records. 3 into 3. 3 into 3, 9. Okay, so in such type of situations, we can use cross join. Not that much important, so we should know. So like this, we can pair each record in one table with another, every record in another table. So for this, we're writing query like this. Select. So from Group A, country name we want. For Group A table, I am giving alias name as A. For Group B table, I am giving alias name as B. So we are writing like this. Select. For Group A table, I am giving alias name as A dot C name. From A table, country name it takes. B dot C name. From B table, country name it takes. Okay. So A dot C name. Okay. We want to concatenate it with versus. Concatenate it with B dot C name. So A dot C name country, we are concatenating with B dot C name. Just a minute, please wait. Let me write once again. System is giving problem here. So select A dot C name is Group A table versus okay B dot C name. From B table country name we are taking. So A table country name versus B table country name. From which tables? From Group A table, alias name is A, and Group B table, alias name is B. Okay, and don't write any JAN condition. If we don't write any JAN condition, that is cross JAN. So this is example on cross JAN. So for cross JAN, don't write any condition. So these tables are already there. These tables are already there in another schema. That schema name is batch Oracle 11 AM. C ## Oracle 11 AM. So there, these tables are already there. I'm opening them. So select star from Group A. So these are, select star from Group A. These are Group A tables. Group A table data. Observe. Group A. Table name is Group A. Okay. 10 India, 20 Australia, 30 West Indies. Next, Group B. Select star from Group B. Okay. Observe here. 40 Pakistan, 50 England, 60 New Zealand. Okay. Next. So two tables are there. We want to join Group A and Group B. Cross join we want to perform. So we are writing select A dot C name. Okay, concatenation operator versus concatenation operator B dot C name. B dot C name. Okay, from two tables we are retrieving. From Group A, alias name A. Group B, alias name B. Okay, observe here. India should play with Pakistan, England, New Zealand. Australia should play with Pakistan, England, New Zealand. West Indies should play with Pakistan, England, New Zealand. So each record in Group A joined with every record in Group A. This is called cross join. So if you want to write in the ANSI style, just to separate these two table names, which keyword we have to use here? Cross join. Cross join we have to write. Okay, and don't write any joining condition. Cross join we are writing. Don't write any joining condition. Okay, observe here. Same result it is giving. 9 rows it is given. So this one is Oracle style. This one is Oracle style. And ANSI style is, this one is ANSI style. This is ANSI style. So to separate two tables, we are using keyword here and don't write any join condition. This is ANSI style. So this is about cross join. So joins topic is over. Now you know very clearly about joins. All types you know. I'm stopping the session here. In the next session, we discuss another important topic, subqueries. Next chapter name is subqueries. Okay. Thank you everyone. See you tomorrow.